Group 2 and Group 7. So let me just have a quick look. So I've gone through everything except for period 3 elements, transition metals, and don't mind that room, it's very messy. I'm going to clean this up. Transition metals, period 3 elements, which I think period 3 elements, apart from the observations, you need to memorize them and the equation. It's such an easy topic, but you do need to memorize the observations, which I struggle with the most, and acids and bases. So those are the 3 more topics I need to go through once. So obviously I'm going to go through all these topics again before Tuesday, and maybe for one more time. But I do have psychology in paper 1, so I might not do as much chemistry revision tomorrow and Sunday. So Group 2 and Group 7. Enough of the waffling. What happens when Group 2 elements react? Lose the 2 outer electrons, form 2 plus ions, having destruction over gas. Why does atomic radius increase? You know this now. If the atomic radius increases, is a bad thing, really. Extra electron shells are added as you go down the group. Each element has extra electron shells as you go down the group. First ionization energy decreases because each element has extra electron shell compared to the one above. Increase down the group. Increase in shielding, extra electron shells. Extra shells, outer electron further away from nucleus, reducing attraction, extra inner shells. Why does reactivity increase down group 2? First ionization energy decreases due to increased atomic radius and shielding, and therefore because it's easier to lose electrons, it's more reactive. Why does multiple point decrease down group 2? Again, metal ions get bigger, larger ionic radius, further away delocalized electrons for positive nuclei, there's attraction, and 2 things that doesn't happen when the metals down group 2, number of delocalized electrons per atom and the charge of the ion. What happens when group 2 elements react with water? Oxidize from 0 to +2, forming M2 plus ions. Very important you memorize that one. Equation of group 2 elements with water, oxidizing agent, and a 5 group 2 metals. So M solid plus 2H2O liquid form M bracket OH squared aqueous plus H2 gaseous. Water is an oxidizing agent. Beryllium, magnesium, calcium, strontium, barium. Very slow, doesn't react very slowly, steadily, fairly quickly, rapidly. You could learn that. I don't know if that's singly charged ions increase solubility down the group. Doubly charged negative ions decrease the solubility down the group. Draw the table solubility. Yeah, you just need to know increase solubility down the group, decrease solubility down the group for doubly charged and for singly charged increases. And the color of all these when they're solid is all white when solid. Okay, now I'm gonna sorry, my phone was out. Go to group 2 and group 7. Obviously, it's part of the inorganic chemistry. We are on group 2. So the trends, we've gone through that. Reactivity of magnesium with water, yes, you do need to know this. The solubilities of the hydroxide. Okay, magnesium hydroxide, yeah. Magnesium hydroxide is sparingly soluble, very low solubilities. Barium sulfate is insoluble. That's literally on the specification. Test for sulfate ions. If acidified barium chloride adds solution containing SO42 minus ions, why precipitate barium sulfate is formed. What group 2 metals, group 2 elements known as? Yes, this is in the specification as well. Alkaline earth metals are an equation of neutralization, H plus aqueous plus OH minus aqueous to form H2O liquid. What is calcium hydroxide? This again on the specification. Calcium hydroxide is slaked lime, and calcium hydroxide is used in agriculture to neutralize acid soils. Magnesium hydroxide is a use of it, using indigestion tablets, antacid. Antacid is substance to neutralize excess stomach acid. Problem with X-rays. Okay, I don't know if this part's in the specification. This is not the halogens. So the use of magnesium in this, solubilities, the use of magnesium hydroxide, the use of calcium oxide to remove sulfur dioxide flue gases. Okay. Yep, that is with wet scrubbing and all of that. Use barium sulfate in medicine. Okay, yeah. So the pass straight through soft tissue using barium will help diagnose problems with the stomach. A key fact about barium sulfates and how barium sulfate works. Opaque X-rays, patients swallow barium sulfate causes tissue showing the structure of organs. And barium meal suspension of barium sulfate. Color of fluorine. So now we're moving on to group 7. So, yeah. fluorine, pale yellow gas, chlorine, green gas, bromine, red brown liquid, iodine, grey liquid. Why is ionization electronegativity decreased down group 7? Larger atoms attract electrons less than smaller ones. Electrons further away from nucleus shielded by more other electrons. What happens when halogens react? They gain electrons when halogens react. And why does halogen become less reactive down the group? Because they become larger, outsheltered further from the nucleus, electrons less strongly attracted. There. Basic rule of halogens: halide. Halogen will displace the halide from solution for halide below in the periodic table. Now moving on to chlorine with water with sodium hydroxide. So chlorine, you get sodium chlorate, so one solution, NaClO aqueous. Through use of sodium chlorate, solution of bleach, cleaning toilets, bleach paper / textiles using water treatment. Say the kind of reaction with mix chlorine with water, disproportionation reaction. Chlorine both oxides and reduce, a mixture of chloride ions and chlorate ions. Two equations of chlorine H2, including the oxidation states. So you've got, first things first, Cl2 gaseous plus H2O liquid from 2H plus aqueous plus Cl minus aqueous plus ClO minus aqueous, or 2Cl2 gaseous plus 2H2O liquid, 4H plus aqueous for 4Cl minus aqueous plus O2 gaseous. What happens to reducing power of halides down the group? Reducing power of halides down the group increases down the group because greater reducing power, greater reactivity, and faster reduction reactions happen. And sodium fluoride with H2S4, all of this, not strong enough reducing agents. Two equations. This. I'm going to skip this part because I already know this on the specification, all of that. Wet scrubbing. Use some calcium oxide removed from flue gases. So acidic sulfur dioxide removed from flue gases by reacting with alkali. Yeah, so that is very important. How is a slurry made? Slurry is made by mixing calcium oxide, calcium carbonate with water, sprayed onto flue gases, and the waste product is a calcium sulfite. But this part, I don't know. This isn't on the specification because all it wants you to know is... Sorry, where is it? The use of magnesium in the extraction of titanium from titanium chloride, right? That's all it wants you to know. It doesn't want you to know how it's purified and all of that. How is titanium oxides converted to titanium chloride? How is titanium chloride purified? What is magnesium used as? Used as extracting titanium from its ore. Yes, that's the only really relevant one. But yeah, I'll investigate that.